There we go. I see an icon. So
This
we're
Hangout
live.
on air is live.
So, hi. I'm going to read an introduction. Apropos is a conversation between Clojure programmers that you can join in live. We're going to discuss a few Clojure news items and share our opinions on them. Then we'll jump into a Repl and code some exercises or do some demos. If you're joining us live, feel free to comment in the chat and we'll try to address the questions. So I'll introduce our panel. We have Mia.
Hello.
We have Ray, Mike, and
Hello.
I'm Eric. Hello. So our first topic is CLJS.main follow-up. Who wants to tackle that one?
What we were talking about at the time, I think, was AOT versus non-AOT.
Right, the different classifier options.
Yeah. So I think, what happened was last time we were talking about that, and as a result of that, I believe things changed. So now ClojureScript is now AOT compiled.
By default.
Yeah.
So you don't need any classifier on it.
Yeah. And if that happens to cause you any problems, then you can opt out of that now by giving classifier slim.
Interesting. So another piece of follow-up related to this is I actually opened up an issue on the fig wheel template. And I was right, they were not using the AOT classifier in the generated dependencies. And I got a comment back that was the problem with AOT dependencies is that they are like if they're compiled, you're not getting and all the transitive dependencies are compiled in too, and so you're not any dependencies that ClojureScript has would be compiled, and then you won't get the new version if you add it as a dependency. And so Bruce Howman, the creator of Fig Wheel, he was concerned that as a beginner, you don't want to be dealing with that. So even though it adds a few seconds to the startup time of Fig Wheel, he would rather have that than someone dealing with having an older version of the code being compiled into ClojureScript. And you wondering why is it not doing what it looks like it should be doing?
Yeah, speaking to that, Bruce was, I think it was about a week ago, he was digging into something and he pinged me. He's like, Mike, what's going on with this? And I'm like, well, that's really weird looking. And ultimately he realized that he had AOT on and you caught him off guard. He's like, AOT. And he turned that off and it fixed it. Was. Yeah.
So AOT is not exactly a perfect solution to all of our problems then.
Right.
In fact, it could be the cause of many problems.
Yeah, so if you are using ClojureScript and the compiler starts to act weird in some way that reflects AOT, you can opt out of that. You can say use the slim jar, which is just the uncompiled pure Clojure code.
Okay, so you have to specify something slim to get out of this default behavior. That's the important thing. That's the important message, really.
Yep, the default has changed, right? Yeah.
So all of this classifier stuff. And this is the bit of the mystery last week, wasn't it, Eric? It was like, well, what is this classifier? So it's just these build targets, and they have different compilation methods, and then you can specify it according to what your needs are. And okay, so summing it up, it's like AOT by default, so you get to the performance, but you can have slim for like standard behavior.
And I think it's about 5 seconds that you gain. So if it works, that's like part of your life you get back.
Right. So it's
or 3 hours if you get screwed by the compiler.
Yeah, exactly. I'm trying to figure out what's wrong. It's a trade-off.
Doing the calculus is quite tricky, I think.
That's quite a long time, 5 seconds, if you're running it each time.
Yeah. I have a really slow computer, so maybe it's not as much for you. I don't know.
Yeah, but who does that?
No, I think it is.
Yeah.
Well,
does
who
that,
does
Noah?
that? I don't know.
The reason I ask is because I just today or yesterday, in fact, okay, I started messing around with Shadow CLJS for a little. I'm doing a little command line thing for work, and I wanted to do it on top of Node. So I looked at how Node by default, how ClojureScript by default has this, and how Shadow CLJS has it, and they seem to be able to consume npm dependencies much more straightforwardly than the standard model does. And I know, Mike, you were saying there's something in alpha around that. But at the moment, it's quite easy to do it through Shadow or CLJS. And with them, you make a build and you just essentially run this server all the time, and it watches your files and compiles it and compiles it and compiles it. And then when you run your program, it's on top of Node, so it takes seconds anyway. So the cost of all this compilation is kind of buried, you know. And when you're running Figwheel, it's like that as well. You know,
Yes.
it's fully amortized, basically.
So where this came up, I think, was in messing around with CLJS main and trying to just run small scripts, you know, from the command line.
Yeah.
And that's where you feel the pain.
Right.
And
yeah.
yeah, so this
Probably
cuts
also-
5 seconds off that. Yeah.
Like I've heard of people having trouble with build times. So if they've got a build step that, you know, they push it to their build server or whatever, and then on the server, it's running like the ClojureScript compilation as part of the asset pipeline, that it adds significant time to have to, you know, because it's going to fetch all these dependencies, and then, you know, 5 seconds could be something they care about.
Would 5 seconds matter, though, if you're really rebuilding your entire dependency tree? Because
it's already 50
you're doing it
seconds.
wrong, you know?
Yeah, just pile it on.
You're already screwed, so 5 seconds, take it, you know. And also, it's a CI system, so it's in the background.
Right.
I don't know.
I think, I mean, this goes back to what we're kind of hinting at with Repl stuff, that we're used to just starting a Repl and, you know, going to get a coffee while it starts, and then just never closing it. And a lot of people are not used to doing that. They're used to, you know, running tests at the command line each time and stuff like that. So it could just be like an education issue, you know, as opposed to like we really need to focus a lot of effort on making this faster. I don't know.
Well, I think inevitably when you first come across it, if you're going to follow that QuickStart guide and you press, we were looking through, weren't we, some of the changes to the follow-up to the CLJS 1.10. Are we going to come on to that, Eric? We're going to do the next thing? We're going to
let's do
talk
the next
about
one.
the README or whatever?
Yeah.
I don't know if I'm like jumping the gun there.
No, I think we're done on that first one. Yeah. Go ahead.
Okay. Yeah, so after the show, for what it's worth, it all went a bit crazy, and then, you know, David Nolan said he has a new QuickStart guide, and he was basically with all these like changes to the compiler and to the way you can do everything on the command line now. You can remove a lot of junk from the getting started guide, and everything becomes a lot more straightforward. And we were just having a quick look through the differences, weren't we, on the GitHub page there?
Yeah, the diff has it's 400 lines shorter.
We can just quickly bring it up even.
I'll paste it into the chat and the YouTube.
We can bring it up on the screen as well. So you can kind of just get a feeling for it on the video, that it's just so all the crossings out, and the you know, even if you don't really follow it fully, you can kind of
right. Just look how many sections are just gone. It's actually quite refreshing. The whole section on Maven is gone. The whole line again section is not needed anymore.
Yeah, you don't need to say hello to the compiler anymore.
And it's even going to get simpler because currently in that guide, there's conditional stuff based on whether or not you're on Windows or Mac OS or Linux. That's basically because the CLJ tool does not yet exist for Windows. And once it does, then that will be another simplification.
Oh, when is that coming?
I have no clue.
Are you caring about Windows, Mia?
No, but I have friends who do.
Okay. Asking for a friend.
Oh, okay.
That's pretty
The other
funny.
thing that I noticed on this one was if you look at this, like what we've got on the screen now, you've got this Hello World core. In the past, you had to enable console print, which was a very annoying little thing. And now you can just say print then Hello World, which is really nice. Yeah.
Is it actually showing up on the main screen right now?
It is, yeah.
Okay.
Mm-hmm.
I'm going to stop that now. We'll just talk normally. Okay.
Yeah, so I'm really excited about this. It's turning into something that you could actually, call QuickStart guy.
Yeah.
It's not like, hey, here's the in-depth and how the compiler works. It's actually, here's a couple commands and it'll run a compile. It's pretty cool.
Yeah, this is the first thing some new users will see, and you don't want to be turned off by all this cruft that you have to do to just get it to compile a Hello World program. Yeah.
Exactly.
Deal with Maven dependencies and all that. No, none of that anymore. Pretty cool.
Yeah. So, Mike, you were saying there were some other big things in 1.10.
I think the biggest thing that we may have mentioned last time was the shared AOT cache feature. And I think we
we talked about
or
that,
did we even?
No.
Oh, maybe we talked about that afterwards. Yeah. So that's kind of.
And also, Mike, it's not in our talking points. So what the hell?
It is.
Oh,
there's a separate thing.
That's right.
There's a
See?
card.
Eric's got my back. Yeah.
There is a card. All right. Okay.
Okay, so you want to go through like the CLJS core specs alpha talking point, right?
I don't mind. It's I was just a little joke.
Yeah.
Mia, are you seeing these talking points, by the way, in Trello?
I actually haven't looked at the Trello.
Oh my God! The dog ate our homework. This is not good.
We have a
So wait, what
deadline.
We're still getting organized, folks.
Yeah. It's all right. It's okay.
I wish you asked me that on air.
Yeah.
Well, it's more fun that way,
Well, okay, so the show starts now.
Yeah.
Okay. So what is this CLJS core spec alpha point that's new in 10?
So let's see. So there is core specs alpha. You have to back up and talk about that a little bit. And that is the specs for the core library. Or at least some of the functions, right? Like, or some of them.
So last I checked, it only had the macros, like the macros that are built into Clojure. It did not have functions.
Right. It is completely limited to macros right now.
Okay.
Like defen. I guess let somehow they did that for a special form. But yeah, it's just a few. It feels like maybe like 5 to 10 macros are covered. And maybe the NS form is another big one, because that's NS form is kind of like where it's really easy to put something incorrect in there.
Right.
So that exists, and that's one of the extra 2 dependencies that is in Clojure. That is why you need deps and stuff like that. So the thing that's in ClojureScript is a port of that stuff to ClojureScript.
Okay.
Yeah.
And so the idea behind these, as I understand it, is, well, they are trying to do the whole core library eventually, but to start with the macros, because a lot of the problems with the macro error messages are that they work just fine when you get the syntax right, But if you mess anything up, you just fall into a black hole of exceptions, and it's not a very well explained error message. Like, oh, you should use a vector instead of that. It's just like, I don't know how to treat this like a vector, and you don't know why. Is that?
I think so. Yeah. Yeah. It's like
Explain
you
it.
want to catch the problem as early as you can, and if you wait until macro expansion's done, then you have a larger mess on your plate to try to pull apart to figure out what went wrong.
Right. So
So
are
these-
the error messages better?
Well, so
Are
if
we
you,
really going to go there?
I think you will get spec errors now. So if you are accustomed to reading spec output, then you can read that stuff. But if you see that for the first time, I would argue you're going to be like, what is that? What does it mean?
Yeah.
Yeah.
But is it better than before? Like, is it a step forward? I guess is, it might not be ideal, but some of those error messages that you see on macro expansion, like, I don't know, like if you forget to put a empty argument vector, you do def and name and you just put the body, like it'll say something like, this isn't I indexed. And you're like, why what's going on? What did I do wrong?
One example, maybe a concrete thing to talk about, is in ClojureScript when you do a require, you can't do refer all like you can do in Clojure.
Right.
You have to give it a vector of the symbols that you want to import or to refer. So if you make that mistake and you try to do a refer all in ClojureScript, you'll get a very cryptic error, and it'll tell you that it can't. It'll tell you that it can't make a sequence. Well, it just tries. It doesn't even check for that. It just goes and tries to do it, and it tries to make a sequence from that keyword all, because it's expecting a vector to be right there, and the train derails, and you have to kind of figure out, what did I do wrong? And if you opt,
I did that exactly today. The only way I found out was by going to look at other ClojureScript to see what, and I actually went back to the manual, and it's like, Jesus Christ! Oh yeah, there's like a manual page this long about what the difference is between the Clojure version of require and the ClojureScript version of require. So it seems like that's required reading.
So
Sorry.
So what you can do now, what you can do, Ray, is you can require CLJS core specs alpha, and by doing that, you'll have these specs in place. And if you make the same mistake, it'll tell you that place right there needs to be a collection, and it'll tell you that all is not a collection.
Oh,
Yeah.
It's
That's
kind of
much
difficult.
better.
It's better.
Yeah, it's better. It's hard to read the spec output because I'm still not used to reading that stuff. But that's what it's exactly telling you. It's like, hey, in this one little place here, I wanted a predicate to be satisfied, which was collection.
But it shows you what you put and what was wrong with it. That's better.
Oh yeah, it even gives you like the little vector path down into the spot that you made the mistake. Yeah.
yeah, the spec output is fantastic. It's got just everything in it. I wish it had new lines built in. Like, I think that's what actually makes it hard to read, because it's got everything you could want in it. It's just hard to actually parse that block.
That wall of text that you see. Yeah.
Yeah, well, I mean, technically, it's like, it is technically accurate. It is correct. It's got everything. You're absolutely right. It's just, human
There's a lot of
parsing
room
that
for
stuff
improvement.
is tricky.
Yeah.
Okay, so rather than going on to that error messaging crap, because we'll be here all night.
Never talk about error messages. Never talk about types.
It's just a black hole of depression, isn't it? So
We'll reserve a show just for that.
right, okay.
One day.
The final show, go down in a blaze of error messages. All right. Maybe we should do it all in French or something, so that most of the people don't understand us, and then it will be very apropos error messages.
And even our cursing sounds like a lot more elegant.
Merde. Okay, so
Map entries.
this ClojureScript core, the alpha thing. I mean, are you saying that that in your just so I can catch up again, Mike? After all the fun, are you saying you have to explicitly include that in your require to get this goodness? as of 1.10, or is that going to be kind of like implicit?
Right now, you have to opt into it, and you have to actually require that namespace. And by doing so, it will register those specs. That's different than Clojure. Clojure evidently has them on from the beginning. So I think ultimately, typically what ClojureScript tends to do is it tends to align with Clojure and match it. So I think that to answer your question, I think in the long run, it probably will just be there all the time. Yeah.
A bit like println.
Yep. You can always rely on println.
Yeah.
It's always there.
Yeah. Well, you couldn't before, but you can now.
That's true. Yeah, you don't have to enable console print. Yeah.
Yeah. We just talked about that, but okay.
That's a new thing in 110, right? That you can.
So when you do the core spec, oh, sorry, Eric, go on. Yeah.
No, I was just I was moving on, but if you're still on specs, that's cool.
I was just going to say that you better make sure you don't refer all, but okay, that's. Yeah. Okay. Moving on, Eric.
All right. So, just because you mentioned it, I was going to go on to enable console print. So it seems like in 110, the ClojureScript has something to like detect if you have a console object, because normally you would do console.log to get some messages, but you can set a thing to print, like your print line will go to console.log instead of wherever else it might go. But now that happens automatically, which is awesome because it sucks to have to remember to do that.
Totally does.
Yeah, one less thing you have to do. Yeah,
one less thing. Map entries. I read a thing about this. It's like another alignment with Clojure, that there's a separate type for key value pairs.
Yeah,
so in Clojure, it's not arrays anymore. I think that's the key thing, isn't it, Mike?
It's not vectors, yeah.
Yeah, so what ClojureScript did do was it didn't have map entries from the beginning. And what it did was it kind of used vectors as, substitutes for them.
Like tuples.
Yeah, two-element tuples. And now it has bona fide map entries that will be produced when you get, like, if you take a map and you turn it into a seq, you will get a sequence of map entry objects. They still print like vectors. It all basically aligns and looks just like Clojure.
But is it like, because underneath it all, is it still actually JavaScript arrays? It just happens to be look like map entries from a Clojure type perspective.
So what they really are is def records. The map entry type is like a def. There's a little def record for map entry, and I think it has a key and a value.
Def type.
Maybe it is a def type. It could be. I think you might be right, Eric. That would make more sense.
The def record would make it like a map instead. I don't know if you'd really gain anything.
Yeah, that's a good point. I'm not sure which one it is. Yeah.
Yeah.
The Clojure maps up to, I think, up to 8 entries are actually sorted hash maps by default, which I found by accident when I updated one from 8 to 9, and suddenly everything broke because things were no longer in the right place. Is ClojureScript, are these maps also sorted up until that point, or are they never sorted?
Yes, ClojureScript has the same. They're not sorted maps. They're not sorted as in. There's a different thing called a sorted map that keeps it sorted by keys.
Yeah.
When you create a map, it's called an array map, the smaller one.
Yes, that's the word. Yeah. Yes.
Mm-hmm. And I think there's like a threshold of 10. It might be 8. I can't remember. But yeah, somewhere around there, it flips over to using a hash map implementation.
Yeah. Okay, so ClojureScript does that too.
Yeah, I think it's always done that, or at least as long as I've used ClojureScript.
I mean, with the new changes to the map.
Yeah, nothing was changed with respect to that recently. Yeah.
Cool.
Yeah.
Now we have reducible sequence generators, which is another alignment with Clojure. That if you do like a range, it has its own type. Instead of range used to be even in Clojure, range would generate a seek, and so it would, it was lazy, but it would actually be a seek, and so it didn't have a reducible. Reducible is an interface or a protocol in ClojureScript that lets do reductions quickly over it. That's like custom reduced implementation. And so this means that it's a special type that's just a range, which is lazy in the sense of it'll only generate it when you ask for it, but it doesn't, it's not lazy in the sense that it won't cache, right? So it only remembers, or it doesn't remember any of its sequence because it'll just regenerate it each time because it's just counting, right?
Yeah, and everything you said about range has been true in ClojureScript for a long time. It's all accurate and true. It's been that way for a long time. And the thing that's new in 110 is the result of what you get when you call iterate, repeat, and cycle. Those three generators are new, and they roughly act like what you just described about range.
Mm-hmm. Yeah. So they're lazy in the sense of generate it only as needed, but not cache any of it.
Yeah. So if you essentially if you try to reduce over one of those, the results of one of those, it will avoid like creating the intermediate seek.
Right.
It'll just like you described. It'll rip through it and rapidly calculate the answer. And there's a huge difference. There's some forms that ClojureScript can't calculate right now because it'll just blow out the heap because of head holding. Because ClojureScript doesn't have locals clearing. If you try to iterate over one of these things and you go too far, you'll have you'll basically blow out your heap. Now with these things you can do that.
So are there some documented wins on these of these cases, Mike? Like people where there's bugs or whatever that have been fixed that are referenced in the release notes?
Well, so there are certain forms that I guess do perform faster, and I don't know if we have like documented wins that show that these things are faster.
Okay.
Yeah.
There's some benchmarks in this news post draft that we have.
Oh, yeah.
Is that what you're talking about? So like they've got some forms that they've tested, they run it 10,000 times or 100,000 times, and it looks like they're seeing speed ups on JavaScript core of 11% faster, V8 18% faster, and SpiderMonkey 105% faster. And if you don't do destructuring, you use key and val. With the map entry stuff. Wait,
I see what you're talking about, Eric.
Two things. I'm reading two different things at the same time. Right. So
okay, yeah.
The reduce. You do
I'm
a
impressed.
I know one eye was like. That was for the map entry thing. So if you
if key value key.
That's
a good point.
Yeah, you get a speed up, and then if you use the reducible sequences, you're getting like 4.5 times faster in some of the engines. So that's a big speed up.
Yeah, they're multiple times faster. And that's also where you can easily run into a situation where you cannot calculate the answer because it just won't fit in memory. Yeah. But with the stuff you can, because it becomes like a pure computation then, It's not.
Yeah, it's not a garbage collection test.
Yeah.
Like how fast is your garbage collector?
Exactly, yeah.
All right, so I think we talked about all of our points, and we're just at time for our Repl stuff. So we're going to switch over to the Repl. So if you're listening on the... Yeah, go ahead.
Before you just said, I'll just have a quick look at the live stream. We've got a few people, actually. I know we announced this a little bit late, so we haven't got as many people as we had last time on the live stream. But we could maybe just have a quick look at what people are saying there. One guy is Daniel Sutton. He's saying that I guess the stuff about keys and all that kind of things, the arrays, is implementation detail not to be relied upon?
Oh, I think that he was talking about the array map there, which yes, it definitely is,
okay.
but it's also an implementation detail that has bitten people in our code base.
Right.
So-
Okay. So it might not be relied on behavior-wise, but it's kind of like, you know,
It's
cognitively,
implicitly.
it's yeah.
Yeah.
Right. They
Right,
should
and-
like randomize them or something in dev mode. Just like the seek should just be random. You shouldn't rely on it.
Also, I'm just going to give a shout out to Haggis42 on there. That yes, you are on air. Hello, Haggis. All right, sorry. So, it's quite nice to have a little bit of feedback from the people listening, and really appreciate that. You know.
Hey, Sean, how's it going? Yeah, we're getting the hang of this. We'll figure it out.
Yeah.
So we're gonna switch over to the REPL, and if you're listening in the audio version, because you might be on a podcast right now, it's gonna end right now, but we're gonna continue on the live stream. So if you want to watch the REPL coding, go to YouTube, and the recording will be up, so you can watch it. Don't do it in your car if you're listening while driving.
Unless it's a self-driving car.
Right,
Yeah.
unless it's in the future and you're in a self-driving car.
Or you're out there, there's just always on our street.
And if you're an AI listening to this and you have the extra processing to listen and watch while you're driving, sure, that's fine too.
Yeah. Also, if you're a passenger in the car, it's okay.
Okay, so with that out of the way, let's switch over to the REPL.
All right.
And it looks like we're going to be doing some exercises this time.
I don't know.
All right.
Give it a try. So we had yeah. Do you want to do this, Mike, actually?
No,
You want to start?
but I will try. Yeah. Okay, so you want me to try to solve the first exercise, or at least introduce it?
Yeah,
Let's see if
maybe we should just say what we're trying to do here.
Yeah, okay.
Or do you want to say that, Mike, or Eric? Eric's the kind of smooth guy.
Yeah.
Oh,
Oh, yeah.
Okay.
Not in that offensive way, you know.
smooth.
Yeah, what are we trying to
That
do
sounds
here?
creepy now, you know. You kind of turned it around, you know.
I think the idea is that we're a bunch of Clojure programmers and we've got experience and different levels of experience and experience in different parts of the systems and stuff. And so it might be cool to see a real live Clojure programmer solving a problem and how they do it in the REPL, because it's something that I hear a lot. People talking about like,
Yeah.
I hear all this great stuff about REPL driven development, but what do you do? How do you really do that? And so let's show people what we do. And I'm sure we all do it differently. But yeah, it's just about seeing a real live person coding.
Yeah, I mean, personally, I almost never do it in the terminal, but, you know, needs must.
Ah, yeah.
Soon we'll all be doing it in the terminal with Rebel read line, right?
Yes.
So we have this shared teamwork system now, and I think it's currently just at the shell, Mike. Are you
Yeah.
going to kick off a REPL or?
I'm doing that now. I'm doing line REPL.
He's in line.
Ooh,
Unless you
old school.
prefer something else.
It's okay.
Yeah, I thought we'd go, you know, one of your home brewed models. Yeah.
There, that REPL started.
Mm-hmm. And we can all type, so
Yeah, that's dangerous.
we'll take turns.
So I'm trying to remember. I think the first problem was that one where you have to
Negate
Negate?
every other number.
Negate
Yeah.
every other number. I'm gonna paste it into the chat, y'all.
Okay. So I'll take the first whack at this, and maybe others can try to come up with different or better solutions. So I'm just going to make a little bit of test data, and what I want to get back for this one, I can't remember if we want to negate the first one or not. I want an answer that looks kind of like this: -1, 2, -3, 4, -5. So this is an interesting problem because you can't, you can't do this, I don't think, with a straight map. Because a map would back and forth. So I'm trying to remember, I think the first thing that came to my mind was using map indexed. That was my way of cheating. Because that will then give you the index of the element that you're working on. Let's see, the way it works, map
It's
index.
a vector, yeah.
Yeah, this feels kind of like a cheesy solution, but it works. And I think if I remember right, it's maybe index. I'll just do doc on it real quick because I can't remember. I can never remember.
Yeah, but this is ideal, you know, to watch how this thing works. Yeah?
Okay, so map indexed, and the function I'm going to pass to it is one that takes, I think, what is that, an index first? Let's see, it takes two arguments, an index
first and
X.
Yeah, index an item. Yeah.
Okay. And what I'm going to do is say if I don't know, even or odd. I'm not sure which way I want to go with this. Even. If the index is even, say X. Otherwise, negate X. You might have this backwards.
Well, the nice thing is we can just get a response and then fix it if it goes wrong. Oops, hang on.
Okay, so my def in was wrong back here, or my def.
Oh, you just had X. Yeah.
X's.
Yeah.
And
that looks right, except so does that map indexed work on a seek, or does it have to be an indexed collection?
Okay, I think I can.
Well, you could just range without. I mean, because you're putting X's there, but that's a bit, you know.
Yeah. I'm gonna just turn it into a. Is that enough of a test, Eric, to just turn it into a?
Yeah, sure.
A quoted list. And try it again.
It does, huh? That's interesting. I didn't know that.
Maybe if the thing, well, so it's not doing like inth on the thing that it's working on, or is it? Maybe it does. Maybe like under the hoods, it has some optimized version if it is an index
I think
sequence.
so. Yeah, I mean, reading the docs, it looked more like it was doing its own counting, right? It was doing 0, then 1, then 2, and not using the actual index from the collection.
Okay, I want to do the source for it. I'm curious now. I never have looked at this. I don't know what it's doing. Oh, now we have to learn how to scroll back. Well, maybe this is good enough. Lazy seek, yada, yada, yada. It looks like it's incrementing the index. You can see a little bit of that down at the bottom.
Inc index. Yeah, so it is doing its own counting. It's not using the... I thought that's the whole point, was it was for an indexed collection. You could also get the index. But this is great. It works for seeks too. I didn't know that. And you don't know how many times I've mapped the 2 vector function or 2 argument function with a range just to get the index, and now I know I could have done this.
And I don't like this solution because it uses indices, and it's against like
implementation.
It rubs me the wrong way. Yeah.
Yeah.
Can I give it a crack?
Yes.
Go for it. Yeah.
Okay, so we have X's. So my first inclination is it looks to me structurally like we should be treating the this as pairs, right? So we can use partition to XS. Now we want partition all.
Yeah.
Right.
Just in case.
And that breaks it up into pairs. And then it's what the second, looking at the example, the second value in each pair become negative. So I could do map. I mean, now I'm just getting into shortcut mode here. I'm just thinking I'll just destructure it right there. and then return x and negative y.
Mm-hmm.
Then I'll turn that into map cat.
Yay. Yep. That one looks better to
This
me.
makes a lot of garbage.
But what happens? Wait, what happens if you run this on an odd number of numbers in the vector?
Right. So let's see. Range.
You'll be missing a y. Huh?
So range 5, range, yeah.
Oops.
Well, partition all should fix it, shouldn't it?
Yeah.
Okay.
Well, you'll get a null for the last y, right? And that'll be the null
Oh,
point.
that's why you're getting that null pointer, yeah.
Yeah.
Ah, you're right.
It should be last.
It should be last.
First and then last, rather than.
Oh, but if you have two pairs and then you're calling last on a vector of, yeah, what happens if you call last on nil? I don't actually know.
It's nil.
Yeah.
Yeah. So that's
It's like when last, isn't it?
I can't think of a good way to fix this problem.
Haven't you got first and then when last minus last?
Well, you could just not destructure it, right?
Yeah.
You keep it as XS.
Okay, yeah.
And then you could do, what is that? You could use a juxt, huh?
Ooh.
Yeah.
Yeah.
All right.
You got me. I think
We're doing real closure
So
here now.
you could juxt identity and negate.
Oh shit.
right, but then
okay.
negate is going to
Yeah.
be, but then you could F nil the negate. How's
Yeah,
that?
yeah.
Oh,
Try
man,
that.
we're getting
Okay, I want to see what that
Definitely.
does.
I mean, holy shit.
identity.
Now, this is
I'm going to do identity first.
Okay.
Why didn't the map
all
cat
right.
work?
Okay. Yeah.
Why didn't the map cat work?
Is that still an null point? Is that still an NPE? I can't actually see the bottom of the screen here.
No, it worked. I mean, it did something.
Maybe try it
I think
without
if you
a cat.
lengthen the screen, Mia, or something, lengthen the Google screen.
Yeah, just see what we're getting out of it. Okay. Do you have to apply juxt identity? Maybe.
No, that's not it. Oh man, but that would just work. So
Wait, where is your
Yeah, but
negate
yeah, it's not a
here?
function,
You
is it?
got- Yeah, where's your negate here? I see identity,
I'm
identity.
not
I can't
even
see-
trying to negate. I just want to
Yeah.
Oh,
reproduce.
this is.
Yeah. Okay. Yeah. So you
Okay,
have those
that's what I
pairs.
expect.
Mhm.
And then if I map identity over it, that should do nothing.
Right.
If I map, oh no, juxt is the wrong
Yeah.
thing.
Yeah, juxt won't work.
Juxt is
Right?
the wrong thing.
Yeah.
Yeah.
It sounded cool.
Um,
It's for swapping things
Yeah.
over, isn't it? The juxt.
Juxt
we're
is
taking-
going to call the two with
The
the
two
same
functions.
argument.
yeah.
yeah.
Once
Yeah,
one
it's
argument.
just-
is the
the
person
like swaps
that's-
thing. You can do all kinds of swapping around. Yeah.
Mhm.
I like def nil though. That was quite a nice one.
Yeah. So let's try that. Okay. Fn x y. The problem is we're going to get a nil in here now.
Yeah,
Yeah.
but if
So
you do
if
f
we
nil,
have-
then you're good, aren't you?
Then you could filter the nil out
No,
at the end
it's
or
gonna
Yeah,
something.
just do a keep. You know, instead of doing a map, do a keep.
Yeah.
Yeah.
Okay. So
Yeah,
watch.
do it. Okay.
Okay.
No, at the beginning.
No. You want it here. You want to get rid of the
okay.
nils while
Oh,
you
yeah,
still
yeah,
have
yeah,
a
okay.
semantic of what that nil. why
Oh,
you
okay.
want
You're going to put
it.
that keep on the
That's
inside.
my
All right.
yeah. That's
okay.
my opinion.
The-
Okay. So
Okay.
then you do f nil minus. Oh, that's not gonna work.
You'd have to put a 0 to make it happy. Yeah.
Yeah, you gotta make it happy. So I would just do when
Do the when, yeah.
negative y. That's
Well,
I think this is semantically exactly what we want.
yeah, yeah.
What happened? Did I keep?
Yeah, you don't need the keep now, do you?
Keep identity, or I'm not sure I think I see what you're
You
doing.
don't need the keep anymore.
Yes, we do. We're gonna have nils in there.
No, because you're winning it, aren't you?
Oh, we have a nil.
Yeah.
Yeah, but then you do
Yeah,
a
but
keep
that-
at the beginning. When you do your map cat, then you do a keep. Then, yeah.
But why isn't the
You want to keep
well,
cat, actually.
Keep cat, yeah.
Keep cat is what you want, but you don't have that.
Yeah, but you can do
You can map cat and then remove nil. Yeah.
before, yeah. Keep before that.
I don't see why the keep didn't work inside.
I think you had to apply it, maybe. Or you had to provide a function to keep.
I don't
That's what
use
you're missing.
keep. Keep use it.
Keep is
What is
map
it?
that removes
Keep is
nils,
map
isn't
and filter at the same time. Yeah.
it? Yeah.
It's like a map and a
It
nil
does-
filter. Yeah.
It takes
Yeah.
a function.
Yeah.
But it takes a function, so yeah.
Yeah.
So maybe it's identity or something on that. Yeah.
I'd rather filter or remove nil. Instead
Yeah.
of using identity,
Yep.
just
Okay.
do what you want.
Yeah. That's better. Yeah. Excellent.
Yay.
Okay, that took a while. I thought the the structuring it into pairs was going to be better. Anyone else want to have a go?
I mean, they're always going to be a sequence, right?
Yeah.
So couldn't you map here? I'm SSH'd in, but I don't think that I can actually
Can you
type
type?
on this thing.
Should be able to.
Yeah, no, I just typed things and nothing came up.
All right.
Oh, okay.
Let me try starting my own Repl here. How did I?
Did you do like the little script to join the tmux?
No, I just ran the SSH.
Yeah.
Do
I
SSH,
think
then
that
you do
I'm missing the
/ join tmux.
There's like a little script there to join it, and you'll be in.
Okay.
You just do
see
/ join and then tab, and it will find it for you.
Oh, there we go. Oh, hello. Oh, wow. Okay. All right. So, couldn't you just like write a little? If they're always going to be sequential, then can't you negate the odd numbers here?
Okay.
And then, is this cheating?
X,
That is
problem with
cheating.
X-
Yeah. You're assuming something about the input, but I like it. Yeah.
Well, I'm assuming
Cheating
the
is
input
fine because you're
I'm
not
assuming
cheating.
the
You
input
know
is
the
always going to be a
inputs.
range, right? Because
Yeah.
if the input is always going to be a range, then
Yeah.
this just always
you're right.
works. If the input is not always going to be a range, then it doesn't. But we're using ranges right now.
It's perfect, I think. Yeah.
So,
Yeah.
I mean, yeah, you're going to know.
but
what
if
you're
it's
doing.
not going to be a range, then we should know.
But why are
So-
you doing it in a function rather than in line? That's the other thing that's kind of funky there.
Oh, because I wrote it in my Repl and pasted it in here.
Okay.
Let me try. When I saw that,
It's fine. I'm not
here's what I want to do to this.
Oh my God, Mia!
Oh, nice. Oh,
Oh.
yes.
And then,
Ah.
can we do this? Get rid of enough stuff to make the fringe balance.
Yeah.
Is that good?
Nice. Try it.
And then up to, yeah.
Yeah, let's try giving it starting at 1 instead of giving it a range.
Well, you can start the range at 1.
Yeah.
Range is more powerful than.
Oh yeah.
Than you could ever imagine.
Yeah, I always forget that it even lets you step, like basic style.
Yeah.
Yeah.
Right.
We should do it. Just do 1, 1 and... Fine, don't do it then.
Yeah.
I mean,
The other solution I liked was the one that's based on cycle.
ooh,
Yeah.
Let's see if I can remember that one. So this one relies on mapping, using the fact that map can.
That's awesome.
You like that one?
You
So
could
if you
cycle identity and negate.
oh,
Mhm.
want to try it, Eric? Let's see.
Yeah. Okay. So
Because I had a
let's-
slightly different one, but I see where you're going now. I was going to map -1 and +1, but I like your solution. Let's see.
Yeah.
we've got-
Yeah,
Yeah.
cycle, identity, and negate.
we've got
So
Vinay
this is an
on the
infinite
live
sequence.
stream that says, "What about a transducer?" So
Oh, good idea, yeah.
yeah, let's go there.
Next week.
You could try
Yeah.
that one yourself and There we go. So let's see. Then
Okay,
we do
so-
map.
I think what they should do is they should type the forms into the chat room. You know.
Map apply x's. I don't think that's going to work. But then what we do is we repeat. Okay, you know why that's not working? Is apply, the last argument has to be a sequence of arguments. And this xs, each item is a single one. So we're going to then do repeat nil. This is giving 3 arguments to apply, either alternating identity or negate, the next item in the sequence, and then an empty sequence.
That doesn't seem nice, though, to me.
You could do map something like, wait, this.
Oh, we've got someone who says that Hayes42 says they wrote the cycle one already. I don't see it.
I've got the cycle one here. Oops, sorry, Eric.
Oh, sorry.
Sorry. I was typing.
I've got your cycle right here.
Yeah.
Like this.
This needs to be a unicycle.
That's cool though.
Ooh.
This was mine. I like where you went, Eric.
Ah, that's cool.
See, I was using math, but I like your functional bridge there.
Yeah, this one
more
now
directly.
is good. Yeah, the one that Eric did was really nice.
I think the cycle thing is kind of cool because if you back up a little bit, it lets you change the problem definition, where you can say not negate every other one, but like what if you said negate like the 7th and the 18th one, you know, or something weird.
Right.
You could produce a cycle that represents the thing that you wanted to operate on in that little group.
Right. The other one was kind of.
What about the ones where it's an odd number though? Like we're doing this like range.
Oh, you're gonna break it.
7.
Let's see, does that still work?
Oops.
Yeah, it works. Mm-hmm. That one's nice.
The 0.
It's more robust.
Negated.
Yeah, they're both.
You can produce -0.
This one gets it slightly wrong, doesn't it?
How?
Because it's not every other one now. It's like 0. Yeah.
Yeah, the -0 is sitting on the front. You just can't see it.
Should be 1 -1 instead of -1 1, but it's the.
Yeah, I had them backwards. I negated the wrong one. Oh, you're flipping the order now.
Yours is shorter.
Yeah, the cycle one's kind of nice and like in code golf terms, kind of nice.
Right.
But this identity negate, you could then do other things. You could do absolute value or something.
This is nicer though, because it doesn't matter whether the compared to the partition, it's much cleaner.
Mm-hmm. And now cycle is free, right? It doesn't do any garbage.
Well, okay, so this is where, okay, so taking that as a riff, you could take what you wrote, Eric, and let me go to the thing, and we'll do a transducer.
Ooh.
Oops, if I could type it. You just do into, and then, oh, you know what? This is going to fail because it's not going to do, transducers can't do the 2-argument map thing, right?
That's right.
If it were like a straightforward map that didn't take multiple sequences, transducers want to work on a single sequence that runs through it. Mm-hmm. Whereas map is fancier. It can work on 1 or more. So that would have been cool if it worked, but nope.
So transducers fail.
Yeah, I mean, is there a way to make a transducer like a?
If you want to work on 2 things simultaneously.
Yeah. Oh, this is a good question we've got a question from the chat about cycle. Can we elaborate on cycle having some built-in state?
I mean, it implements the seek interface, so it doesn't really have any state. It just like the seek elements that it creates know where it is in the cycle.
Yeah.
And so it's just pointing into the sequence. If that's
Isn't it like a lazy generator essentially?
Mm-hmm.
And it's now
Except you
directly
can-
reducible. So
Yeah, it's its own type, and it's got like you could do this like def C identity negate,
okay.
and it's stateless. Like two threads could use the same C.
Yeah.
Sorry, that's not what I meant to do. Cycle. Two threads could read from the same C at different points and not conflict. It's not like an iterator where it's stateful.
And that's part of what makes it so that certain functions are amenable to this directly reducible concept, where if you reduce it, it's basically going to calculate out in advance without producing the seek. And therefore it needs to be able to, like, you can't do it to something that's got a random component to it.
Mm-hmm.
You can't have a directly reducible thing that would, because you have to actually, if you have like a repeatedly rand, and you're basically producing a sequence that's rand, you basically have to store that sequence as you generate it lazily. So that's just kind of an interesting thing about cycle, is that it is, you can recalculate it whenever you need to. You don't have to store the whole thing. Yeah.
Mm-hmm.
And I bet that there's some reuse. Is that true? Like for instance, with this version of cycle, you really only need two instances, because anytime you call like rest on it, it's just going to give you the other one, because there's only two elements. So it could cache the two and just keep returning each other, right?
That's true.
Yeah, and like as an optimization, it just never has to create any garbage.
The other thing I thought was maybe we'd like show that we can just have an infinite sequence there. Because we don't do that. We don't do that very much, do we? Where we show kind of infinity,
We don't want to scare people. I have to go. I have a meeting.
No problem. We're up. Time is up. Yeah.
So, bye everyone.
This was fun.
Brilliant.
Yeah.
Cheers, Mia.
See you later, Mia.
Bye.
I think we'll start to wrap up. Yeah.
Yeah, we had another exercise, but I guess we won't.
Yeah, we'll do it next week.
Yeah.
Or next time, whatever. Yeah.
This was fun. Yeah.
Yeah.
I like this.
We said at the beginning, actually, if you remember, that these kind of exercises would take us down all kinds of little rat holes, and it's kept us busy for 20 minutes or more. So.
Yeah. And we realized, like, the first time I saw it, I thought, oh, surely this partition thing's going to work, because I know there's partition all. Except it didn't work because of the nil case. Oh.
And also keep as well, like you say, where exactly you put keep in the pipeline, and there's all these extra little funky things going on with this cycle stuff. Yeah.
Yeah, I tend to dislike these kind of blanket. Oh, and then just flatten it, or then just remove all the nils. I don't trust them. I don't know.
You mean because having nils in the collection, you might end up, it might be blow something up on the way through.
It's kind of like masking over, I think, right?
Yeah,
you don't like the masking effect.
Whereas if you remove the nils like right where you generate the nil, at least you still feel like, okay, I know that I'm doing it. Like, it's right here. I'm just going to remove it before I pass it to the next part of the pipeline.
It's more composable as well, I think, that way, because if you're emitting nils, then you kind of you make it less consumable by other functions, don't you? Because then they have to take care of it.
Right.
I agree, though. Flatten is kind of like a function that you can abuse. You can hide a big mess with flatten.
I think
Yeah.
it's nice for structural purposes. I mean, you know, it's kind of one of the annoying things about, and this is where we'll go off on a little tangent here for 2 ticks before we clear up. Is like this. I can't remember his name now. He did is it Nathan Mars? The guy who does Spectre.
Yeah.
His argument was that it's just kind of a problem where you have this deeply nested structure, and when you do these functions over them, if you're not careful, you end up getting back some weird shapes. You know, you get seeks rather than vectors, and you get sequences of maps, which you then got to unflatten and, you know, unfold and reshape. And he's right. You know, once you get to a certain level of depth, it becomes problematic.
Yeah. For sure. Like, I don't know, what happens if you flatten a map? I've never done that. Like, I just never use flatten. I would rather know at each stage, okay, I'm doing a map cat here that's taking it's only removing one level of, let's do it.
Not a lot.
How did that happen? I would have thought it would just be a sequence of the key value, key value, key value.
Yeah, we learned something.
Don't do that, children. Don't try this at home.
But this is like a way to rapidly learn stuff, is to like go through these problems together, because then you can be rapidly exposed to a lot of ideas like this. Yeah.
Wait, that's two
sequences. Oops. Yeah.
This.
Yeah, I don't even know what it should do.
No, you need,
because I don't use it often enough.
One sequence.
Okay, a sequence of maps. What would you get out of that?
A sequence of maps.
A sequence of. Get rid of the vector though. Converts it from a vector to.
I don't like flatten. Yeah. Takes any nested combination of sequential things, and returns their contents as a single.
So if you have this as just
you put another nesting on there.
Yeah, like 1, and then you have 2. Then in theory you should.
Right. Yeah. So it knows the difference between sequential and collection in general. That's seekable.
Yeah. I mean, it makes sense for it.
No, that's a topic in itself, isn't it?
Yeah.
Indeed.
Right. So I think we're done, yeah?
I think so, yeah.
I quit.
This is pretty cool. You quit? Okay.
No, I'm joking.
You want to have flatten removed from the language, otherwise you're going to...
Yeah, just veto that.
Yeah.
All right, guys. Well, It's been good. Let's sign off then. Thank you very much for everyone that's watched or whatever. And do you want to put a little tail on it, Eric?
Yeah, everyone who's listening, watching, everything, mash whatever buttons give a positive signal to the AIs that are telling us what to watch in the future. And that will help us be watched more and gain world dominance in Clojure live casting. Thank you.
Cool.
See you next time. Join us on Twitter, because we announce if you subscribe on YouTube, you'll get an announcement. It'll like notify you when it's coming up. And if you're on Twitter, we all retweet when it's time to join up live. So follow us on Twitter, Apropos Cast, and on YouTube.
Bye.
See you later.